So I am so excited to introduce Mike Arellano, who is the Deputy District Engineer at the Austin District at TxDOT. So we're going to hear about smart mobility. Let's get started.
All right, so I got everybody here with nice full bellies, and my task is to keep you awake, right? So it's interesting that the title of this conference is Texas Driving AI Revolution. If you saw my profile picture, as you can tell, I'm not 10 years younger. That's just AI. So it does miracles today, even in that time that you can see that it even enhances my look. So AI is doing miracles, truly. Today I'm here to talk to you about what we're doing here in the Austin area as far as smart mobility. We talk about the future of smart mobility, but a lot of it's already here, and I'm really excited to kind of share what we're doing here locally. The previous presenter said, you know, the tagline for the University of Texas is what starts here changes the world. I think what's happening here in Central Texas is actually changing the world and how we're approaching smart mobility. Well, this kind of just level set for today. So today, I've been around transportation for 28 years, and what I think is new, is 10 years ago, I think is new. But today, it's better than what we had 10 years ago, but, still not sufficient, right? We don't have a sufficient infrastructure on the ITS side. We don't have full coverage. A lot of the technologies we even had out there that we deployed 10 years is now obsolete. And, we have a bunch of basically disjointed data environment. So it's great that we have all these OEMs and all these vehicle data out there and all this crowdsourcing data, but it's not integrated, right? So if you ask the USDOT, our future would look like this, ideally. And so this actually gives us a good architecture to strive for in how we have these cloud-based solutions to kind of integrate all this data, whether it be roadside data or vehicle data or any other types of data. So a very data-driven environment. So how do we get there? So this is kind of the progression that we've come up with on generation of technology on the roadside digital infrastructure. Traditionally, everybody, especially in the metro area, is probably around generation 2. It's conventional ITS systems that we have around today. I'm glad to say here in the Austin area, we're actually around generation 3. And that's because we have actively and successfully integrated and deployed AI. And so AI is driving all of our traffic operations and all of our traffic management, which I'll talk to you in a little bit, which actually provides a lot of integrated real-time data from all that crowdsourcing data that we talked about, third-party data, vehicle data, all of our ITS data, which inherently gives us really low latency information and data to go by. More importantly, it gives a lot of great outcomes from that gives us the ability to actually actively make our system much more efficient. Today, we're striving to get to the next step into generation 4, where a lot of our edge computing and our roadside equipment has that compute power. And so we actually have some projects trying to develop those standards. So when I was asked to put technology in the ground of that capacity about 2 years ago, I was asked to put something into play that we had no design criteria, no standards, no pay items, and nothing, basically nothing to design around. And so I'll tell you how we overcame that challenge, and we're delivering that today. So the 5 emerging technologies that we've been embracing and trying to implement is first and foremost data management. So we have designed a back end to manage the data. If you start on the roadside, you're generating a lot of data that doesn't go anywhere and isn't as useful as you want it to be. So in the Austin District, we developed a data management system to integrate all those various data that we talked about. And so we did that with an AI platform with machine learning that basically transforms all that data into actionable insights, increases our scope and efficiency and how we can actually respond to our traffic environment. Can't do any of this if it's not connected, right? So we're working with our MPO to have a long-term plan to make sure we have the connectivity we need, whether it be fiber, cellular, or any other type of communication. Because all that data generation and AI platforms is pretty useless if it doesn't communicate and it doesn't integrate. So we're having a very active, very creative and innovative way of trying to do that. We're talking about joint duct agreements, reciprocal agreements with other telecoms about occupying empty ducts, to try to basically address that gap in connectivity. Last but not least, everybody's talking about CAV and enabling that. As we know, perception and sensing of AV is limited to the sensing range of the car's capability. We like to increase that range by providing that two-way communication and provide those OEMs real-time data. By doing that, we need that edge computing to actually do that communication, those observations, to give, increase 200 to 300 meters into 200 kilometers. If we can give that much insight down the roadway, it gives those autopilot, Blues Cruise, whatever you want to have in your car, a lot more insight and capability to make quicker, more intelligent and accurate decisions, much more in advance. So how are we doing that? So about almost 2 years ago, we did a proof of concept, and we had a procurement, and Recor won that procurement back then, and we've been using it ever since. This is their official AI platform. So like I said, you got to design the back end to basically integrate data. And there was an approach previously to purchase data and create data lakes. Our approach is to create pipelines of data, very specific data. We have a very decentralized approach where if we're getting it from third sources or local governments or whatever the source is, they manage their data and we only request specific data. By doing that, we can ingest those specific data sets into our common platform, and that we're doing that today. And I'll show you how that looks like when you start interacting with local governments, mobility, transit, and other agencies. So what that does, we're able to ingest all this infrastructure, OEM, third-party data of very specific data sets. And what it does, it gets that, again, we had that very disparate data environment. It starts to fuse that using machine learning. So as we speak, our AI platform is machine learning, so it knows what normal congestion looks like. It knows what normal operations, so that when there's an anomaly, it actually pops it up to our operators in our traffic management center. And if those OEMs can ingest that data into their onboard units, it'll tell them directly or on their phones. So it provides real insight to our operators in real time. And I'll show you the efficiencies that creates and what the outcomes of that is. And so by doing that, though, and bringing that data into one pane of glass in our traffic management center, not only are we seeing that, but also our TMC partners are. So law enforcement, first responders, our hero operators on the roadway. So they're able to monitor, detect, and respond quicker. That type of data sharing and efficiency, I'll show you the benefits of that, but ultimately what it does, it increases mobility, and more importantly, it promotes safety. So here are some of the benefits. And so actually these metrics are a little old. If everybody's familiar with traffic incident management systems, this is kind of the timeline from when an incident starts to when you get back to normal operations. So one of the major interruptions to mobility is either a stalled vehicle or a crash, right? We've all been stuck on an interstate or a major corridor in our major cities, and we're wondering why we did. So clearing these things are very important because what they often do is not only cause queues, but they cause secondary crashes, which can often be more severe than the actual crash that occurred. It might just be a stalled vehicle causing that queue that results into a fatal secondary crash. So every minute counts. So you see these minutes differences, but those minutes are exponential when you start looking at the response and the results. And so what happens is our AI platform gives us data-driven incidents and insights happening on the roadway that we cannot observe with a human eye and camera. And it can handle hundreds of cameras and images and process those images much quicker than a human being. And so today, traditionally, if we have our TMC, we have about 12 to 14 people on the floor. Everybody's seen a TMC, right? We're at the big center, we have all these people on the floor, a bunch of monitors looking at cameras, right? That's a very conventional, traditional way. We still do that today. But we've been operating with this in the background with two operators. So you go from an efficiency of 14 to 12 people to 2, doing split shifts on a single pane of glass. And what happens over time is they quickly are confident in what the insights are giving them because they've had very successful, so basically they're doing it blind because they can't see it visually sometimes. Again, we don't have insufficient cameras, right? So a lot of times we don't have full coverage. And if we do have cameras on it, a lot of times the way you expand and zoom in, you can't even get onto the incident. So basically, the data is telling you something's happening. So what happens is that operator can say, okay, something is happening here. There's a high level of confidence. There's a high priority. They'll dispatch hero or law enforcement. The first day we ever implemented this platform was at 10 o'clock in the morning. By 12 o'clock at lunch, we detected 3 to 4 incidents that our cameras and our human eyes could not detect. And we dispatched and came to normal operations much quicker. So as you can see, that cumulative efficiency has created a shorter amount of time that we get to normal operations. So here are some of the metrics that we've done. So talking about the University of Texas, they're our third-party evaluator. So they're looking at the data. So we trust the data, but we verify the data, right? And so they're doing a third-party evaluation, and they're confirming that these numbers that we're seeing and these efficiencies are really true. So conventionally, we use computer-aided dispatch or CAD information. This is basically when somebody finally calls law enforcement, 911. That's when time zero starts, okay? That's when somebody actually reports it. That's conventional today. Or we see it on a camera. That's when time starts. So how much more time are we seeing it relative with AI versus a conventional call-in or visual by an operator? This is what we're talking about. So this is the compare and trust. Conventional, what we do on the CAD system versus our AI. As you can see, and I'm going to go over all of them, but we have a higher percentage of incidents and crashes detected. Some of them are crashes, some of them are not. One of the important ones that you see there, we're 44 minutes faster returning to normal operations. That's huge. How many of you want to be in traffic 44 minutes less? Right? So one thing we've seen is our level of service and mobility on I-35 has increased without adding a lane, only because we're getting rid of incidents that block, whether it's a crash, ladder in the roadway, or anything, much quicker because of this. More importantly, that fourth one, a 29% reduction in secondary crashes. Since we're clearing that incident much quicker, because AI is given a data-driven, real-time, low-latency information insight, and we can respond quicker, we're saving lives. We're getting back to normal operations into safe operations much quicker. As you can see, when we start looking at precision and number of incidents detected, AI is superior in this analyzing the data and the machine learning, detecting when there's issues on the roadway. Speed. Our AI is about 34% faster than conventional call-in, look on the screen. So we're getting it faster, we're getting more accurate, and we're clearing much quicker. So here's the other thing that, we're talking about those 5 emerging technologies. What this enables us to do is when we have a common platform like this, is partner with our other agencies. So this is actually a diagram, an architecture, talking about the decentralized approach to data. So Cap Metro, Travis County, RMA, City of Austin, they all have their own data. And we don't want to manage it all. But we want very specific data. So we have very robust workshops trying to address a certain issue. In this case, we're about to do $23 billion of mobility and infrastructure projects in Central Texas for the next 10 years. So on top of crashes, another disruption to traffic is construction. And I'm sure everybody loves the fact that I-35 is always under construction, right? Well, that also causes lane shifts, detour shifts, work zones change, and they also cause a lot of crashes, unfortunately. But wouldn't it be great if you knew that? So not only are we the ones doing mobility projects, but so is Cap Metro. They're doing Project Connect. City of Austin has their bond projects. So not only is your state system going to be infiltrated with work zones, but also the city streets, the county streets, mobility, everything. So we were working together in good conscience to the public to try to notify you as soon as possible, and our AI platform has provided that common environment to basically ingest and manage all that data in a very efficient way. And so by doing that, data sharing becomes much easier. By having decentralized approach to data has become much more efficient to integrate that data. So we can generate APIs like this for very specific data, and it really ingests to the machine learning. As you know, machine learning The more data, the more robust and the more accurate it is, and the higher the quality is, the greater the outcomes. And that's that's what you saw in those fatality reductions, and that's what you saw in that return to normal operation. Oh, sorry. Talking about the University of Texas, they're down there, CTR. CTR is our third-party evaluator. They make sure all these systems are working and integrated correctly. But they also provide the traffic demand modeling for the whole region. So their traffic demand modeling feeds into the AI platform to really discern between irregular and regular congestion. I know it sounds weird, right, in Austin, regular congestion. You know, it's a very low bar for us. So I won't go any further than that, sorry. So this partnership is called the Central Texas Construction Partnership. So you see all those agencies, and so we're currently under an interlocal agreement that we're doing data sharing. We have so this is actually a proof of concept for a larger concept. This is gonna be a smaller, if you want to consider I-35 and integrating data for the whole region, smaller. This is going to be a proof of concept for integrating our data for our whole MPO, all surrounding 8 counties. And so, again, this is a proof of concept. This is actually going to determine our regional data governance and how we share data, our cybersecurity, our privacy security. All these things are going to be wrapped up into this relatively small proof of concept project. More importantly, it's going to inform the public all the upcoming events. So our machine learning actually takes in events too. So it's already seen South by Southwest. It's already seen a UT football game. It sees what it does to the network. So when you throw in a crash into there based on the traffic demand modeling from UT, it can machine learn and actually reroute you whether you're coming from Round Rock or Kyle. This has kind of all come into fruition into an app, which you'll see come to the public in January. Right now we're in alpha release, and so all of our interagencies are kind of messing around with it. What's interesting is, so I get emails from our TMC about a crash or a ladder in the roadway, and I get about, 10 a day? From our machine learning app that drives this app, I get about 10 an hour. I mean, the frequency of stalled vehicles, the frequency that the AI, the machine learning can detect actual actionable incidents, it's at such a higher rate than we ever thought. It's annoying because I turn off the notifications because it was just continuously at night telling me something is happening, which that's one of the feedbacks I might give on our evaluation of the app. I just want to point out 2 individuals in the audience. Brenda, she's our Director of Traffic Operations, and Carolina, she's our ITS manager and engineer. Brilliant young ladies, and they're helping me with all this stuff. So if I sound smart, it's because I have smart people around me. But they're helping me implement this stuff. So we've kind of solved the back end part, integrating the data, how to use that data, how to ingest that data, how to turn it into actionable responses. The second level is getting real data off the roadway. So all the data we're talking about, say third-party data, the vehicle data, cell data, the latency and the accuracy, questionable sometimes. The best data you can ever get is what you measure and observe, right? And so CTT TVs have been great, but a camera with that compute power to have that imaging detection, that's even better, right? So we're talking about, I came up with a scope of work and basically a request for a proposal about 2 years ago now. Again, I was asked to come up to deliver smart mobility technology. We don't have specs, we don't have design criteria, we don't even have pay items. So what I did, I don't know if I have that in here or not. I'll just describe it. So the only thing I can think of is have a design build approach. I know what my KPIs, I know what my use cases are. I stated those, I stated constraints on law, whether it's on PI, cybersecurity. And I told everybody, propose, how would you solve this problem? And so we got several proposals. Cavndu won the project. We're currently in the delivery stage of that. We got 100% plans. We're about to deliver it. But this is a suite of sensors and cameras and software technology that they proposed. And so this is going to provide that low latency, accurate data on the roadway. It'll be able to discern classification of vehicles, speed, whether you have a deer or a hog crossing the street relative to a person. It'll have that ability to have that machine learning, that compute power within the sensors, within the cameras, that will be ingested into our centralized AI platform for more AI machine learning for our operators to respond to. Additionally, as you can see the V2X component to it, it will be real-time launched out to whatever vehicle can ingest that data. So again, we're talking about CAV operations. If your Tesla, Ford, GM, whatever you're driving today can ingest that data and inform your autopilot, it can make a better decision, or no, more importantly, you can make a better decision to have a safer route, a more efficient route, if you know if something's coming up, not just 200 meters away from you, but 20 miles from you. And if the machine learning is informing your platform that South by Southwest is happening and you have a crash here, what's your best route? In that app that I talked about that our CPP program actually has, it has a week. The goal is to have a trip planner, not just for a day, but for a week. If we know that South by Southwest or football game is going to happen, we know our closures on I-35 are going to be XYZ from this time to that time, these lanes also. It's going to take all that into account into your commute and give you recommendations on when to leave your house, when to leave work, whether you should stay home. I mean, telecommuting, I mean, that's a thing now. Teleworking is a thing. Or it can give you multimodal options. We're even talking about if, depending on the mode that you take, that you will get carbon credit for it. So we're talking about ingesting all those different features. Is it a navigation app? No. What it does, it actually partners with your favorite navigation app. It's a companion app. So it informs your navigation app. So you don't have to get rid of Waze or Google or Apple. It'll once you figure it out, your planner for the week, it'll say what app, what navigation app do you prefer. You click it, it informs it. But if we actually have real-time data showing, hey, a crash just happened 10 seconds ago, and it can go from this cloud to our cloud-based AI back to you either through your phone or your onboard unit, then we have addressed the most important part of addressing Vision Zero. So our roads are as safe as they've ever been designed. They're as safe as they've ever been constructed. Our cars are as safe as designed and constructed as they've ever been, but we continue to see deaths on the roadway rise. Why? Because we haven't addressed the driver experience. If we're not addressing the driver experience and giving people information to make better decisions, we're not addressing the biggest opportunity to reduce fatalities. And this is what that does. It gets low latency real-time data from the roadway. It gets it to an AI platform that can ingest all kinds of other information to provide the best decision that you can make and your car can make in a low latency standpoint. So I was asked for keys to the future of smart mobility. Connectivity, communication. None of this happens if we're not connected. So we're really, as a region, trying to push to get fiber everywhere we can, and where we can't, try to get cellular, trying to get broadband, because everything has to be connected. Because none of this happens if there's no pipeline for that information to get down. And so, unfortunately, the most unconnected roadway in our district is I-35 downtown, because it's our oldest. That won't be the case for long. It'll probably be one of the smartest interstates that we have in the country based on these designs. Regional collaboration. Partnership is powerful. We all have a very specific data, right? If I'm a transit agency or I'm a toll facility or I'm focused on pedestrian and bikes and stuff, you put all that data together in a very concise, accurate way, an efficient way for data governance, you got a very powerful combination. We've already seen it today. This in our collaboration, in our construction partnership, we're proving that all that data together, it makes a very powerful tool for us to be more efficient in our mobility and safer. So that collaboration, it's really informing our future, this little project we're doing, a proof of concept, and how we're going to collaborate in the future as a region and how we do data governance. And in that data governance, that'll unlock all kinds and discover all kinds of efficiencies in how we can interoperate between all of our agencies. More importantly, when you're talking about CAV, if we don't have this, you don't have consistent operations, right? We need interoperability. So if you're an autopilot on an interstate and you go to a city street, it should be the same experience. So this data governance helps govern that. And that's what we're trying to be forward thinking and how we're developing this data governance. Strategic partnerships, I kind of talked about that a little bit. TxDOT's a regional leader, but we can't do it all. We need our local partners. City streets are just as important as interstates. Trail paths, bike lanes, bus lanes, all those different modes, if they can all work together, we can actually have a very powerful combination, especially as the city densifies. Again, alternative delivery technology, I'm not sure there's a conventional way to do this. Because as you all know, technology evolves by the second. And it's hard to get a standard or any type of design criteria that can evolve to that degree. So so the way I delivered, like I said, was a design build approach. So we got proposals, but in that contract, it's performance-based services, okay? So there's performance, there's KPIs, uptime, latency of data, type of data. And in that vendor is responsible for maintaining and operating to those KPIs. If they need to change out an RSU because it's obsolete and it doesn't get their KPIs, that's up to them. That's a no cost to the public. On the flip side, they can keep the data. They can monetize the data within constraints. They can't break state law. They can't give out personal information, all that stuff. But if a vendor can actually monetize that data and sell it back to the OEMs, they make their money that way. The public gets a service for free. So that's kind of how that contract works. Luckily, I wrote it fairly well. And so other states are actually adopting it. I know Florida and Ohio, Michigan, and other states are looking, other DOTs are looking at that type of delivery. There's no way we can go state low bid. There's no way that Brenda's crews can adapt that quickly to technology changes, and it would be very, very costly to the public. That deployment of that technology project would cost the public $9 million. We're building the civil part out for what, 4? So 4 on top of 9, so about $13, $14 million turnkey. So we're getting a $14 to $50 million project for 4. Not a bad deal for the public. Secondly, so you remember I talked about those generations? As we go from one technology to the other, we talk about the evolution and the changing evolution. We don't know the impact or the outcomes or the trade-offs when we go from a 5G chip to a 6G chip. We don't know what the impact is on the flip side of all those different types of technology softwares, different types of hardware. That's why TxDOT and the MPO is sponsoring Texas Smart Track. So talking about the University of Texas, what starts here is going to change the world. This is going to be our official certification center. So if you want to be a software, data, hardware, whatever solution for smart mobility, you got to pass these hurdles at Texas Smart Track. So there's a closed track that's basically looking at a safety protocol, looking at cybersecurity on campus. It's a 3-tiered system, so that's tier 1. Tier 2, you can't really see it. So the blue roadways are there. Those are the existing roadways at the Pickle Center in North Austin. That's more of an open network to continue to test all those different technologies. Ultimately, though, you see it all the way to the right, that orange circuit, that is public roadways. That is TxDOT roadways. So the roadside equipment technology project we talked on 130 is the first leg furthest to your right. So the hope is to build all that out. And so OEMs can go out, and of course, most smart tracks or test tracks are kind of focused around the car. The difference between Texas Smart Track and those tracks, this is focused around the whole transportation ecosphere, from the impact on pavement and infrastructure, cybersecurity, and all those different things. So Texas Smart Track is going to help us capture all the benefits from the market and give any vendor a clear path to market by going through these protocols. And there'll be ISO standards and all that kind of stuff. Public outreach. As a public servant, I have the duty to say we're doing our due diligence to make sure everything we're doing is safe and it's exactly what we're saying it's doing. Texas Smart Track will help us do that, ensure that, and has a public outreach arm to say, hey, we're doing this when it comes to automated vehicles. I think that's all I had. Any questions?
We are at time, so we could take one question.
Oh,
Go ahead. Start in the middle. Here.
So you said your partner state Smart Track is actually looking at all of your risk profiles associated with this approach. So do they apply an AI look ahead as to actually what the potential failures, misuse, abuses could be with that system as it's deployed and that third party's working with it?
Correct. So in the physical world, it simulates exact situations and conflict points that you would see in any transportation system, but also leveraging the supercomputer on campus with the fastest supercomputer in the world, only fifth to two government supercomputers in China and US. So it can push every simulation, every modeling, and every component out there at its highest speed and look forward and look forward at how to see all the implications of all those different technologies.
Amazing. Let's give Mike a round of applause.